Alright, so this last section in Chapter 7, we're going to revisit a old topic that we looked at earlier in the course, but slightly different at the same time, if that makes any sense. So, back in I think it was Chapter 3, we looked at systems of equations with two variables. But now we're going to look at systems of linear equations in three variables. So we're just adding an extra variable to the whole thing. So you know, other than that, this section is pretty straightforward and pretty short. So what does a linear equation look like? Well, so a linear equation in three variables takes this form: ax plus by plus c equals d. And the letters a, b, c, and d, they're all values. They're all numbers that are not zero. So, you know, a linear equation in two variables looks like this a little bit. But now we're just adding on a CZ term. That's the only, this is two variables, but we're dealing with three variables. I'm just writing this out for comparison. So, you know, here's an example of such an equation. 3x minus 5y plus 2z equals 8. This is just one of an infinite number of examples that you can see. So when we had an equation in two variables, or a system of equations in two variables, so we had two equations with two unknowns, the solution was an ordered pair. If you remember from when we did that in Chapter 3, that's, you know, a little while ago. But now that we're dealing with a system of equation in three variables, we're not going to have an ordered pair, we're going to have an ordered triple. So an ordered triple is just the triple pair, well, it's the triple x, y, z. So basically our solution is going to be an ordered triple and not an ordered pair, because we have three variables, so each variable is going to have a value associated with it. They're going to have a coordinate with it. So and we say the ordered triple is a solution if it satisfies the equation. And if we solve a system, it's going to satisfy all the equations in the system. So this is a very straightforward example. If we want to verify that this ordered triple satisfies this equation, just plug it in here. So I have 5 times x, which is -3, minus 2 times y, which is 1, plus 4 times z, which is 7. So if you do the math on that, hopefully you get 11. So you get -15 minus 2 plus 28. -15 minus 2 is -17 plus 28. -17 plus 28. Well, if you need to do it in your calculator, -17 plus 28 is 11. Hey, so it satisfies, because that's the right-hand side of the equation. So does this satisfy the equation? Yes, it does. So, you know, very few surprises there. So how do we solve a system of linear equations in three variables? Well, if you recall, solving a system of two equations with two variables. So if you recall, how did we do this? We did that in Chapter 3. Well, there are two methods. I'll jot them down here. Substitution and elimination. So those are the two methods we have for solving a system of two equations with two variables. And technically they both work in the three variable case as well. However, there's just additional steps we have to look at. There's a little bit more algebra to it than that. So I'm not going to go through this process here. Like, this is reading this verbatim. But I'm going to go through it when I do the example on the reverse side. So what we're going to do is I'm going to follow that process for this example here. I want to solve this system of equations. So what I'm going to do in this system is I'm going to identify, and I'm basically all I'm doing is I'm following this process right here. Just to keep track of my equations, I'm going to label each equation with a number. That's equation 1, that's equation 2, and that's equation 3. So what I'm going to do is I'm going to make two other systems from this original system. So I'm going to make two systems. I'm going to break this system up into two separate systems. So in the first system, I'm going to have equations 1 and 2. So I'm going to write them out here. X plus y minus z equals -1, and -4x minus y plus 2z equals -7. So those are equations 1 and 2. And now in this system, I'm going to pair equations 1 and 3 together. Okay. So, you know, this is equation 1, that's equation 2. This is equation 1, that's equation 3. It doesn't matter that one of them is repeated. I mean, that's going to happen. It's up to you to decide which two go together. Equation 1 and 2 go together, equation 1 and 3 do it. You could do 2 and 3 and 2 and 1, and that's up to you. One of them is going to get used twice. Alright. So now what I'm going to do is I'm going to pick one of the systems. I'm going to start with this one just because it's on the left side. Now what you're going to do here is, so if I follow this process, select a pair of equations, and I'm going to eliminate a variable. Now I'm going to select this pair, and I'm going to eliminate a variable. In this system. Which variable do I want to eliminate? Now I could eliminate it by doing, which method do you think is going to let me eliminate a variable? The elimination method? Duh. So remember, how do you do the elimination method? You add the equations together so that one of the variables are going to cancel out. Now if I add these equations together, what variable do you think is going to cancel out? Well, if you look at it, x and minus 4x, that's not going to work. But hey, look, I have y, and I have -y. That's pretty nice. So if I add these equations together, y and -y, they're going to cancel out. So I'm going to eliminate a variable. So I'll just jot down here, by using the elimination method, I could cancel out the y variable above. So let me add those two equations together. X plus y minus z equals -1, and minus 4x minus y plus 2z equals negative 7. So if I add them together, x plus negative 4x is minus 3x. Y plus negative y, they cancel out, which is beautiful. Negative z plus 2z, that's going to be 1z, equals negative 1 plus negative 7 is negative 8. So now what I get is I get an equation in two variables. Alright, so what I'm going to do is I'm going to hold off on that equation. And now I'm going to go to this one. Now, which equation or which variable did I cancel out here? I chose to cancel out y. Now, you could cancel out x or z. That's up to you. It's just y was already set up to cancel out. That's why I picked it. But here's the thing. Since I canceled out y in this one, I have to cancel out y in this one. I have no choice. Since y was canceled in the first system, comma, y must cancel in this system. That must happen. So if I chose to cancel out x, I would have to do it here, and so on. If I z would be here as well. So now I gotta, if I want to use elimination here to get rid of y, what should I do? Well, if I add these two equations together as is, the y's aren't going to cancel. So if I want to do something to make that happen, what do I have to do? Well, I have y here and I have negative 2y. So if I add these together, I have to have a 2 here, don't I, to get those to cancel? So in order to do that, I got to multiply the first equation by 2. So let's do that. So when I multiply the first equation by 2, right, and then I have 2x minus 2y minus 5z equals 7. So when I multiply this by 2, right, here's what I get. Distribute the 2 to everything. So 2x plus 2y minus 2z equals negative 2. And then the other equation is right there. Minus 5z equals 7. Now when I add this system, my y's will cancel, which is what I want, because it happened here. Alright, so now when I add these, I have 2x plus 2x, which is 4x, minus 2z plus negative 5z is negative 7z, equals negative 2 plus 7 is 5. Hey, what's this? This is also an equation in two variables. And as it turns out, it has the same two variables that this one had, x and z. So now what I'm going to do is I'm going to bring these two together as a system. So this is going to be negative 3x plus z equals negative 8, and 4x minus 7z equals 5. So there's the other. So after doing all this work, I made a system of 3 equations with 3 variables into a system of 2 equations with 2 variables. A lot of busy work just to do that. So basically what I did is I eliminated the y variable from this system and got this system. Now you know how to do this. You know how to solve a system of 2 equations and 2 variables. We did that in chapter 3. You could use substitution or elimination. It's up to you. Personally, I think elimination will work best. So if I have negative, so now I'm going to use elimination. Well, I could either use sub or elimination to solve the two-equation system. So I'm going to multiply the first, I'm going to get rid of z. So I'm going to multiply the first equation, because when I add these together, I have a negative 7 here. So I'm going to multiply this one by positive 7. So I'm going to multiply this one by 7. Alright, so when I do that, let me go down here. So when I multiply 7 throughout here, I'm going to get negative 21x plus 7z equals negative 56, right? And then I'm going to have 4x minus 7z equals 5. And when I add them together, the z terms are going to cancel. Beautiful. And I'm going to have negative 21 plus 4 is negative 17. X, that equals negative 56 plus 5 is negative 51. Divide by negative 17 and you get x equals 3. Now, that's one coordinate. Remember, the solution to this is an ordered triple. This is just one coordinate. I need to find the y coordinate and the z coordinate. How do I find that? Take this, plug it into either this equation and this, or this one to find z. So I'm going to plug into either one of these. I'll choose the second one. So I'm going to plug that in here. So I'll have 4 times 3 minus 7 times z equals 5. 4 times 3 is 12 minus 7z equals 5. Subtract 12 from both sides. So I have negative 7z equals 5 minus 7 is negative 7. Divide by negative 7. And z equals 1. Alright, we're almost there. So now I have two coordinates. I have the x and z coordinate. So how do I get the y coordinate? Well, you take this coordinate and this coordinate and you take both of them and you plug those two into either one of these original 3 equations. So I'm going to take this and this and plug it into either equation 1, 2, or 3. I'll pick 1 because it looks the easiest. So the first equation is x plus y minus z equals negative 1. So that's going to be 3 plus y minus 1 equals negative 1. So 3 minus 1 is 2, plus y equals negative 1. Subtract 2, y equals what? Negative 3. So my ordered triple, or my solution set, is the ordered triple 3, negative 3, 1. And this ordered triple satisfies all 3 of these equations. Now, when it comes to solving a system of 3 equations with 3 variables, that's really it. You know, that's really it. Actually, there is a way to do this in your calculator to check it, and you may or may not have seen this. I mean, it's not something you really have to understand in this course, but if you go to a higher level math course, you would benefit from looking at it. We can actually solve this system using what we call a matrix, and there's actually a whole course with that. It's linear algebra. Linear algebra is basically solving systems of equations of any size. Sometimes 10 equations with 10 unknowns. How would you solve that? And you could keep going with that. But you can actually use it in matrix to solve this. And without boring you with the details, your calculator can do this. If you look right up here above the inverse button, you have the word matrix. So if you hit second matrix, you can actually make any size matrix you want. You could do this. What this means is I have a 3x3 matrix, a 3x1 matrix, a 3x4 matrix. Don't worry if you don't understand what this is. It's not a big deal. But basically what a matrix is it represents all the unknowns. It's the coefficients in front of each variable. So if I want to make a matrix of this system, the coefficients in front of x, y, and z is going to be 1, 1, negative 1. In the second equation, it's negative 4, negative 1, and 2. And in the third, it's 2, negative 2, and negative 5. So if I want to solve this system, and I'd have to use some higher level math, but if I want to do my calculator, I'm just going to use this. I'm going to use this matrix. So this is a 3x3 matrix because I have 3 rows and 3 columns. So if I edit the 3x3 that I have, as you can see, I could type in those values into this 3x3 matrix. So if I do that, 1, 1, negative 1, negative 4, negative 1, 2, 2, negative 2, negative 5. So that's my matrix. This matrix is multiplied by the matrix x, y, z, which is the variables of these equations, and this equals the matrix negative 1, negative 7, and 7. This matrix is a 3x1 matrix because I have 3 rows and 1 column. So if I go back to that, hey, I have that right there already. A 3x1 because I have 3 rows and 1 column. So if I edit that matrix, matrix B, I could go down there and edit those values. I can make that into negative 1, negative 7, and 7. So now if I get out of that, now if I want to solve this system, what I could do is I can multiply both sides. If I want to find what x, y, and z are equal to, I'm actually going to multiply this equation, or this matrix, by the inverse of this matrix. Don't worry if you don't understand it. That's okay. This is higher level math. It's just a neat little calculator trick I want to show you. So to do that, the inverse button is right here. It's x to the negative 1. That's the inverse button. So if I go to matrix, I want to multiply this matrix by the inverse of this one. So what I'm going to type is I'm going to type the inverse of this matrix, which is A, times this matrix, which is B. So I'm going to do inverse of that matrix, which is, this is matrix A. So the inverse of that is going to be that. I'm going to multiply that by matrix B, which is this side. So I'm going to go to matrix B, hit enter, and I get those values. 3, negative 3, 1. Those are the values for X, Y, and Z. What did we get? 3, negative 3, 1. 3, negative 3, 1. Booyah. So that's how I know what my solutions are for that system. Don't worry if you don't understand that. It's not a big deal if you don't. It's just a way to check it in your calculator. You would do that in higher level mathematics. But, you know, your calculator is a pretty powerful tool, man. Okay. So yeah. That's how you solve a system with 3 equations and 3 unknowns. And guess what? That's the last section of chapter 7. So yeah, not too long. So yeah, that's the end of the video.